Alright, 3.7. I just want to write that again. 3.7 Real World Problems Algebraic Reasoning, top page 178. You have used models, diagrams, and tables to translate verbal descriptions and algebraic expressions, blah blah blah. Go down to after Donovan gives Mabel 6 pairs, she has x plus 6 because we don't know how many Mabel has. We weren't told. If Mabel gives 1/3 of her pairs to Nelson, how many pairs does she have in terms of x? So for this, start off with, we've got Donovan, Mabel, Nelson. I always start off with the 3 different ones, figure out one thing at a time. We have, let's see here, Donovan gives Mabel 6 pairs. So, hey, he's giving this person 6. So she has x plus 6 pairs. The problem even tells you that much. So now we know she's got, hey, x plus 6. If Mabel gives 1/3 of her pairs to Nelson, how many pairs in terms of x does Nelson have? So Nelson's got x plus 6 now, but it's 1/3 of that. So he's got x plus 6 divided by 3 pairs. Why don't I have to put the parentheses around that? Because I don't have to put parentheses around that. Why not? In past problems, why did I have to put parentheses around problems? Because they're what? It's not just when negatives are involved. Parentheses are only when you have addition or subtraction in the middle of it, because those are separating out the things. So right here, this is x plus 6. Yes, there's addition inside of it, but because there's this division thing right here, it tells you, hey, you do this, then you do that. It's basically like you're putting parentheses around this. When these are on top of it, you assume you're doing the top thing first. Now, if you're putting that into your calculator wouldn't know, so you'd actually have to put it in your calculator that way. But otherwise, it's fine the way it is. So Nelson has x plus 6 over 3 pairs. You can see in your book, the book also simplifies it. Remember, that could be x over 3 plus 6 over 3, which is 2. Or you can say 1/3 x plus 2. Any of them, if you do, this is adding, remember. If you do these ones, you're going to have to put the parentheses around it and label it pairs, because now you've got the addition thing separated. Any of those answers works though. This one doesn't need to have parentheses. Top of page 179. There are n apples in a box. So that's n. But 5 apples are too green to eat. So that means, hey, these 5 ones, they're green. Aaron and Barry share the ripe apples in a ratio of 2 to 3. So if there's a ratio of 2 to 3, how many are there total? 5. So that means of what's left, we divide that into 5 sections. Now this is the thing that some people make a mistake with. They'll be like, hey, there's n apples, 5 of them were green. All right, these ones are all ripe. There's 5 sections. Okay, there's how many apples total? What? That's what people think, right? This says it's split in a ratio of 2 to 3. Does it say that there is 2 and there is 3? It just means there's a ratio of 2 to 3. So that could be 2 to 3. That could be 4 to 6. That could be, let's see here, 6 to 9, so on and so forth. That can be anywhere on up there. All that means is, hey, you've got 5 in here that are green, and the rest of them are split in that 2 to 3 ratio when it comes to simplest form. So Aaron and Barry share a ratio in 2 to 3, so Aaron must be 2, and Barry must be 3. How many ripe apples does Barry get? So this is the one we're looking for. How do we get that in terms of n? And we got an idea. Where do we start with? What's the first thing we were told? Go back. What? Yeah, so we have n. What's the next thing you do to n? Yeah, subtract 5. Then what? We had n, we subtracted 5, now what? We're trying to figure out berries, remember that. Not like these we're talking about apples, but it's berry, the guy's name is berry. Don't get confused with the fruit that are berries. You look confused, don't be confused. So what we have here, berry has 3/5 of what's left. That's what we have to remember here, because it said, hey, this is split into five sections, or 2 to 3. It's split 2 to 3 among them in the ratio. Aaron gets 2, Barry gets 3. Barry gets 3. That's what we're looking for. So he has 3/5 of what's left. So that means you can say, hey, 3/5 of n minus 5. See how I got there? It's the same thing. This is definitely the way. Normal 7th and 8th graders cannot do this stuff. It's because our book teaches it this way. Or I shouldn't say they can't do it, it just becomes a lot more challenging. Writing this out, the diagram out like this is going to help you guys a lot. So, and then we just have to label apples, I believe. That, in my opinion, is the easier way to do it. It does give you at the model 2, where you just use algebraic reasoning. You're like, okay, I use n minus 5, then I take 3/5 of whatever's left. That's going to go to Barry. If that works for you and you can do it that way, do it that way. You don't need to do it. You don't need to do it this way just because I think it's easier. If it's easier to you, go for it that way. I'll say the majority of kids, that's not this is the easiest way still, but do what works for you. And if you look in there, they do have ways that you can simplify, I should say. You could actually distribute this, so it becomes 3/5 n minus 3/5 times 5. Cancel it out. Becomes 3/5 n minus 3, and then you can label it apples. I don't know what that last letter is. It looks kind of like a bean if you put together. Alright, and we're just going to do this one guided practice. Actually, let's do guided practice 1 and 2. Next page, page 180.